Hello and welcome to Vodcast 15.7. In this podcast, we will tour the Jovian planets. Let's begin our journey by visiting Jupiter, the lord of the heavens and the largest planet in our solar system. Jupiter's combined mass is 2.5 times more than the combined masses of all of the other planets. In fact, had it been about 10 times larger, it would have been a second sun in our sky. So imagine waking up, going outside, and seeing two suns on the horizon. Jupiter takes about 12 years to orbit the sun, but it rotates extremely rapidly. In fact, a day on Jupiter is only 10 hours. Jupiter has a multicolored banded appearance, and the bands are aligned parallel to Jupiter's equator. I sometimes refer to Jupiter as the Illini planet because the bands are orange and blue. Those bands are probably a result of chemical reactions occurring in Jupiter's atmosphere. But the bands themselves are generated by the wind system's very rapid rotation. On Earth, winds are caused by the unequal heating of Earth's surface by the sun. But on Jupiter, the winds are powered by heat energy coming from Jupiter's interior. Because of Jupiter's immense size, gravity compression forces provide energy for enormous, large storms. And perhaps one of the most famous features on Jupiter is the Great Red Spot, which is a counterclockwise rotating cyclonic storm located in the planet's southern hemisphere. The picture shown here doesn't do the storm justice because you could fit 3 Earths inside of that storm. Jupiter has 67 moons, but I'm going to focus on the 4 largest moons discovered by Galileo. The outermost moon of the 4 major moons is Callisto, and it's densely cratered just like our very own moon. The next moon in is Europa. It's the smallest Galilean moon, but it might be the most interesting moon in our solar system due to the fact that it may contain more liquid water than all of Earth's oceans combined. Europa has an icy surface that's quite flat, but evidence strongly indicates that underneath that icy surface, there's a liquid water layer, and that layer of liquid water is extremely deep. For all we know, there could be water-based alien life forms that exist on this moon, and NASA's planning some future missions to investigate this intriguing alien world. The largest of Jupiter's moons is Ganymede. The 4th and final moon of Jupiter that I'll overview is Io. Io is the innermost Galilean moon, and it is very volcanically active. Being so close to Jupiter, Io is stretched and squished by Jupiter's immense gravity. And all of that gravitational stretching and squishing provides heat energy. As a result, Io has more than 80 active sulfurous volcanic structures. The next planet I'll overview is Saturn. And Saturn is widely considered the most elegant planet in our solar system due to its awesome ring system. The rings you see in this image are actually made of water ice and rock pieces that range pretty drastically in size. Some of those water and ice pieces can be as small as dust grains, but others are larger than school buses. When you look at the rings, they look solid, almost like you could walk on them, but you could not walk on the rings. Saturn's rings were discovered by Galileo in 1610, and even with a very basic telescope, if you go outside at night and take a look at Saturn, you will see these rings very clearly. Some other notable characteristics about Saturn are that it takes 29 Earth years for one revolution around the Sun. It's also worth noting that Saturn is less dense than water. If you had an ocean large enough to drop Saturn into, it would float. Saturn isn't all that different from Jupiter in terms of its atmosphere, its composition, and its internal structure. Just like Jupiter, Saturn must have an internal heat source because it emits roughly twice as much energy as it receives. And that internal heat source likely comes about through the gravitational compression that exists on this very large planet. Saturn has 62 known moons, and they vary significantly in size, shape, surface age, and origin. But there are 2 moons of Saturn that I'd especially like to focus on. The first of which is Titan. Titan is the largest of Saturn's moons, and it's the 2nd largest moon in the solar system. But what makes Titan especially interesting is the fact that it has an atmosphere very similar to Earth's atmosphere. It contains a large amount of nitrogen and it's relatively thick. Now here on Earth we have rocks, and under just about any naturally occurring temperatures on this planet, rocks will be solid. But what's interesting about Titan is it's really cold there. So the rocks on Titan are actually made of frozen water. Now you might be thinking that because water is only in its solid form on Titan, that there's no liquid on Titan. But that's not true. Titan has lakes and rivers of liquid ethane and liquid methane. So imagine flowing rivers and lakes of hydrocarbons. In fact, Titan has weather just like Earth, and it can rain ethane and methane. The liquid droplets of ethane and methane would be much larger than Earth's raindrops, and they would fall to the surface much slower than our raindrops. In fact, it's not out of the question that there could be life on Titan. And what's mind-blowing is, if there is life on Titan, it would not be water-based life. So what that basically means is, if there is life on Titan, it would have to have evolved completely independently of Earth life. The other moon that I'd like to focus on is Enceladus, because Enceladus has what's known as cryovolcanism. And what that basically means is there are geysers of pure water coming out of this moon. Shown in this image is an eruption of magmas derived from the melting of ice. And what it's basically showing is water being sprayed into outer space from the interior of this moon. Enceladus, just like Europa, has an icy surface, but underneath that icy surface there's likely a large layer of liquid water. Could water-based life exist here as well? It's possible. But as I've said many times before, NASA is planning missions to investigate these possibilities. The final two planets that we'll overview in this vodcast are Uranus and Neptune. As alluded to in a previous vodcast, you can think of Uranus and Neptune as twins. They have very similar sizes and compositions. One of the striking features about Uranus is that it's known as the sideways planet. It rotates on its side. So if you imagine all the planets in our solar system is rotating like a spinning topwood on a table, you have to imagine Uranus is tipping over on the table, but still spinning. Uranus takes 84 Earth years for one revolution, and it too has many large moons with varied terrains. Now let's shift our attention to Neptune, which is the windiest planet in our solar system. Neptune will take 165 Earth years to complete one revolution, and because of its really dynamic atmosphere, it houses a storm very similar to Jupiter's Great Red Spot. On Neptune, the storm is known as the Great Dark Spot. You can see how big the Great Dark Spot is here in this image. And this image also shows the presence of cirrus clouds very high up in Neptune's atmosphere. The blue color you see for both Uranus and Neptune is due to the fact that there are high amounts of methane in the outer regions of these two planets. Okay, that concludes this video podcast. We have now toured all of the terrestrial and Jovian planets in our solar system. And in our final vodcast for Chapter 15, I will overview comets and asteroids.